First, I will quickly introduce CSCS, that is the Swiss National Supercomputing Centre. It's located in Lugano, and it was founded in '91. Our, let's say, main objective is to develop and operate high-performance computing and data research infrastructure that support world-class science in Switzerland. I always forgot this, but okay. We are around 130 people, and 100 are located in Lugano, and we have also offices here in Zurich. We are around 22 nationalities. So about CSCS, the data center is quite big, is around 2,000 square meters without any pillar. That enable us to have very big machines in any size, in any format, because usually HPC machine comes with different shapes as usual bare metal hardware. This is ALPS, our last machine. These nice fancy colors are because there were during the, let's say, the inauguration days. So I took this picture for the presentation. And here you can see some pipelines about the cooling system. The cooling system is quite interesting because we have free cooling. We take the water from the Lugano lake, we pump it to and we pump it to the data center. We take the water from 45 meters down in the lake, where the water is always all the year long 6 degrees, and we use this cold water with some heat exchanger to cool down the HPC machines. Then when this water comes out from these machines, we use it to cool down normal islands with bare metal and commodity hardware, and the water will come out from there around 27 degrees. And this water then is used from Lugano for heating purposes. We are using it to heat the school campus the new school campus in Lugano and some houses. And then we pump the water go back to the lake, and we have also some micro turbines there to gain a little bit of this difference of 8. We can gain still 75 kilowatts. About ALPS, let's say the key feature, I will go fast here. The key feature are the V clusters. So this means that we can, usually HPC are very big machines, and you will have a Slurm that is the, let's say, the main tool that enables you to use the machine to submit jobs, and it schedules on the nodes. Usually you have a big machine and you use it as a one big machine. V clusters is a technology that we are developing and enables us to split this HPC machine in smaller clusters, and in this way we can have different use cases, different version of operating system, of kernels, and whatever we need. And another nice and key feature is that is not heterogeneous. I mean, it's heterogeneous infrastructure, but with different kind of nodes. We have NVIDIA GPUs, we have AMD GPUs, we have x86 nodes and ARM nodes. And everything is managed from a single control plane, and from there we can manage the machine. So this is ALPS. Peak performance are 434 petaflops. We have around 100 petabyte of scratch disk, and the most, I mean, the way that I like most is are the NVIDIA GPUs. We have 2,600 nodes with the great hoppers, and they are really performant in AI. So this is why this machine was built for that mainly. About the storage, I'm not a storage engineer, so I will go fast through here. The main storage is Lustre. We have Ceph also for everything related to cloud native application and clusters. Vast Dcache is related to the grid technologies, and tapes for backups and so on. Okay, so I quickly introduce the key components that we are using in our infrastructure. Harvester is an open source, let's say, hypervisor that enables you to have virtual machines, but it's based on Kubernetes. It uses KVM and KubeVirt to manage virtual machines. And the storage management is done via Longhorn. Rancher also enables us to help us in managing all the clusters. So we can, from a single instance of Rancher, we will manage all the Kubernetes cluster that we have at CSCS. Helps us in scaling them, in managing them, and is also very, very nice because you have an interface that you can give to the users, and they can see the status of the clusters. It helps you also in security. Yeah.
I just have a question. What hyper-converged means?
This means that you can have one single point, let's say, infrastructure where you can have multiple kind of machines, but use it in the same way. Yeah, maybe you can answer it better.
Look at it as appliance in the box. So basically, you have the compute, storage, networking being defined within that infrastructure. So that's what it means. Everything in one box. Look at, let's say if you have a physical server, what are you going to have in the physical server? Just the physical server. That's compute, storage, and the network card. Right? So it all comes to that.
Okay. So just like a scaling up, like a whole data center.
Exactly.
That has everything.
Exactly. And then you can actually have additional nodes in order to build that concept infrastructure.
Nice.
Yeah. Sorry.
Thank you.
Yeah, no problem. And thank you. And in our case, yeah, we have different kind of hardware, different kind of nodes, different kind of storage. So we can have one single infrastructure where we can use and have everything from there. So yeah. ArgoCD is another tool that we are using. This helps us to deploy application on the clusters. It's also open source, and it helps also the users in deploying application to the cluster because some people doesn't have experience in Kubernetes, but they are developers, so they need to deploy something, and ArgoCD helps them in deploying application in the clusters. Okay, so about our infrastructure, so about Rancher. Rancher is deployed on 3 physical machines and is the starting point. So from Rancher we deploy then everything else. It's based on RKE2, that is the Rancher, let's say the distribution of Kubernetes. We have 3 nodes. Each node expects 1 pod of Rancher running, so this means that if we lose 1 physical machine or 2 physical machines, we still can survive. We have KubeVip on top of that in order to manage the load balancing. The node management are made through MAS currently. We are trying to get rid of MAS, but yeah, we still need to find another solution. And the RKE2 on these 3 nodes is installed via Ansible, and the Rancher itself is installed via mchart on top of this Kubernetes cluster.
Why do you want to get rid of MAS?
I actually don't like it so much, because really is very powerful, but each time they release something new, or each time there is a new version of it, is a disaster for us, because we have scripts that runs on top of that to maybe deploy 10 or 20 or 50 nodes at once. So each time we need to go back on our scripts and check what is wrong, why it's really difficult to maintain. But actually it's very powerful, because it's nice, because you can really take one machine and move it from one kind of let's say VLAN to another one, or redeploy it, change the operating system. You can really manage them as virtual machine, but are. And yeah, so this was Rancher. Harvester, I go quickly through that. So we have 16 nodes, and Harvester itself is also a Kubernetes cluster. So we on top of that, Harvester came as a, let's say, as an ISO image. So you just deploy it on your machine, and then you start adding machine, and you will have a Kubernetes cluster. On top of that, then you can create virtual machines. We have multiple networks on top on those machines. So we have the 100 gig networks that is dedicated for the virtual machine traffic, and then we have the Harvester management network that is on 25 gigs. This means that everything related storage, live migration of the virtual machines, everything related to the Kubernetes networking is done via 25 gigs. And all the virtual machines are going out to through the 100 gig network. Longhorn, so quickly, Longhorn is a cloud native storage. It helps us in having, let's say, in one single cluster, you can have a distributed storage, let's say, for free. This is on Harvester, but we are also using it on some bare metal clusters, and it's very powerful, easy to set up, and it helps you in having one, let's say, easy way to use your local storage on your machine and for your Kubernetes cluster. Where we run Kubernetes, so on the upstream cluster, so on Rancher, we run it also on bare metal, on virtual machine, on Harvester, and also on VMware, and on ALPS also, that is our HPC machine. So an overview of our tenants where we deploy Kubernetes. We have Rancher, as you can see, and each column is an host. For example, SUSE virtualization, you can have a single virtual machine on top of that, and this makes then a Kubernetes cluster. In the case of ALPS, we use an hybrid version, an hybrid way to deploy it. So we will deploy some virtual machine on Harvester, and then we will deploy Kubernetes on top of the HPC machine, and together they will make a Kubernetes cluster. Why we do that? Because HPC worker node, they don't have disk, so they don't have persistence. If we reboot the node, we will lose the persistence. So we need to keep the master node out of ALPS, and also because one node in ALPS costs a lot, so it doesn't make sense to have a master node on 200K nodes, and also doesn't make sense to have a web interface running on top of one node that costs so much. So HPC worker nodes are just there for very heavy load, for I/O intensive or CPU intensive or GPU intensive. We also deploy on VMware and on classic physical nodes. Okay, so how we deploy? We use a declarative approach. we define the cluster. We define the variables of the cluster. We define the network where we want the cluster, and then with Terraform, with some community providers and also some custom providers, we deploy the cluster. What happens when we do Terraform apply, or now we are using Tofu, so what will happen when we do Tofu apply? It talks with ArgoCD, it creates a new repository for ArgoCD. It talks with Rancher, it set up everything on Rancher, so it creates the cluster definition and everything there. Then Rancher will talk with SUSE virtualization, that is Harvester, and will set up all the virtual machine that you need. And in minutes, so around 6 minutes, 5 minutes, you will have an up and running cluster. Something similar is for VMware. We are also using there the Terraform providers, and for the custom cluster, custom is means that bare metal nodes. So this can be bare metal classic nodes or HPC nodes. The only difference there is that the node need to already be set up. So you need already have you already need your node in your right VLAN. You need a node in the right network configuration and everything. So, and once this is done, you just need to run on the machine. You need to run the join command to join Kubernetes.
The VLAN and everything, you do that through MAS.
Yeah. In ALPS not, because it comes with its own management system, but yeah, for the normal machines, in MAS you put the machine in the right VLAN, and then you just need to join the cluster. So about GitOps, so we are managing around 56 clusters, and with one single ArgoCD instance, and we are using the apps of apps approach. So each cluster is an application of an application. So this, what happens when you need to deploy a new cluster, you just, as I showed, you set up the new cluster, then you configure inside the ArgoCD repository which application you want to deploy. That is, can be a simple Nginx, whatever you want, and ArgoCD will take care of take this manifest and deploy it on your cluster, and it maintain also it in a consistent way. So if you are on the cluster and you delete something, ArgoCD will take care to rebuild it in case of deletion. So he maintains the status of the application. We are managing around 750 applications across more than 50 clusters now. And another very nice feature of ArgoCD are the application sets. Application sets enables you to have common application deployed on all the clusters. For example, that can be Cilium configuration or CSI configuration, or maybe automated, so the DNS like Cert Manager, or like external DNS, or whatever you need on all the cluster. So common feature that you need to deploy everywhere are deployed via ArgoCD application sets, and also changes are done via application sets. So if you need to change the version of the external DNS, you just need to change it once in the main repository, and this is then deployed on all the clusters. The most interesting part maybe is the automated DNS and certificates, because this for the developers is something that each time they use it, they are so happy because they don't need to take care about getting SSL certificate or DNS entry and whatever. So they just can deploy their application, whatever version they want. They deploy in ArgoCD, and they in 1 maybe 10 seconds later, they already have the application up and running, because in ArgoCD, we are using webhooks. So each time you do a push on the repo, ArgoCD knows it immediately, and it automatically deploys what is the new changes. Something also very interesting, and that we are already some months that we developed it, is Cured. Cured is a very nice tool to manage reboots of the machines. This is for security reason, so is something that our security team decided to ask us, please do updates, because as usual. And we, okay, we need to find a solution. So what we did is we found Cured. It just check the node. If you have, for example, a Kubernetes cluster with 10 nodes, you just update the packages on all the nodes on the machine, and then Cured will take care of checking the status of your node. It will check the reboot needed flag on your system, and if a reboot is needed, it will drain the node, will take care of the draining and everything, it will reboot the node, and once the node is back on service, it will go forward with the next one. So you can do rolling update easily with this super easy way. About observability, as I said, we use ArgoCD with application set to deploy everything to all the cluster, and currently we are using the Elastic Bits, but we are going away from that, and we are migrating to OpenSearch and the Victoria Matrix. We will use Prometheus operator and to deploy all the monitoring we need on all the cluster, and this enables us also to use the standard dashboards that we can find from the mixing one. They are doing a great job, because we can find really standard for the standard tool that everybody uses. You can really easy find the dashboard that are already set up. You don't need to stay there days in creating dashboard, because it's really a pain. And sometimes if then the tool change, you also have to change your dashboard, your data is different, so it's that. And instead of FileBit, we will then in the future use FluentBit.
Can you comment in 2 sentences why?
Why we are going out from, because Elastic is very good. Elasticsearch is very good, but is extremely expensive if you want more feature. We have a cluster, a very big cluster, because we are collecting logs from HPC, from everything. We have a very big cluster, and we asked for a quote, and the quote was around 250k francs, and we said, okay, no, I mean, we stay with the free version, but we need a feature like YDC integration. We need feature like all this searching in the snapshots, and so and they were not so, let's say, open to give us, let's say, academic license, because we are academic, so we don't do money on top of our system, so we do research. So, and so we decided to go to OpenSearch and the Victoria Matrix. This is a view of how we deployed our observability stack. It's still a POC, and we still need to go in production. We will have, for each node in each cluster, we will have a FluentBit that collects the logs of the node. And then we will also have a Prometheus that will do scraping on all the needed service that we want to have matrix. And new introduced also the OTLP collector, the OpenTelemetry collector, that is very nice, similar to Logstash in features, so you can really collect from everywhere and send wherever you want. Yeah.
How do you expose all that to yourselves, to the end users? Because you've got lots of data stores there, right? So how do you get it exposed?
So about the data?
Yeah.
Yeah.
Some sort of UI or?
Yeah, everything via Grafana.
Oh,
Or
okay.
in Grafana currently with Kibana for the logs. But we are using Grafana for let's say for the dashboard, and yeah, in the future with OpenSearch it is called dashboard, and that's it. Victoria Matrix is very powerful. Is also less storage expensive because it uses less storage than Elasticsearch. So this for us is also quite important, even if we have a lot of storage. I mean, it's better don't use it for free. Okay, let's talk about Kubernetes.
Do you have some audit trails or stuff like this?
Yeah, so audit bit was used at the beginning.
Yeah.
We still have a small cluster, and we Elasticsearch cluster with for the security team that they are, let's say, testing, and probably we will just buy a license for that small cluster. So because the Elastic is very good in that. So for security, probably we will stay on Elastic. We still don't know. We are testing it, but yeah, we still need to check, and we are also testing Wazoo. That is based on OpenSearch. So, but this is something that the security team is doing. So yeah.
With the OLTP, you maybe add a hash on and then you're in.
Yeah, no, of course, yeah, that's true. But we have so many nodes that, and I mean, I'm not in the security team, so they don't have so much experience on Kubernetes and so on. So they still need to investigate what is better for, let's say, checking the audit of yeah.
So a related question: how long you are keeping logs?
Depends. So some kind of logs we also put them on tape because we need to keep them forever, at least 10 years. So for we still have the logs of our old HPC machine. In case we need to do some debugging or some hardware, let's say, I don't know how to explain this, because we also help the developer of the HPC machine to find out hardware problems and so on, and keeping the logs. This helps also them for finding new problems or things. But depends on what is the application, but it can be 6 months to 1 month. Kubernetes Matrix, we keep them for 1 month. If you want.
I was more interested in customer-facing logs, so logins from customer, their IDs, timestamps, and so on, because they are also considered not sensitive, but also,
Yeah, but everything is still internal, so we don't have anything exposed, and also most of the things are NDA. Because yeah.
I can as one of the tenants that runs on CSCS, we do ask for some retention policies for logs based on what the requirements are for our applications. But yeah, for compliance reasons at the moment, we ask CSCS to store them, but we don't have access to them. So Grafana dashboards and stuff, they're also observability is more CSCS facing right now, but it's an ongoing conversation to see how that can be customer facing.
Yeah, because some part of the machine are NDA, so you cannot, the people cannot see, for example, the node name or hardware serial number, or all these parts are really between, the machine is HPE, Cray, it was Cray, and not I don't like it, call it so much HPE, but yeah, Cray, and NVIDIA also, the Grasshopper nodes. There are parts, bugs, or whatever happens that can't be exposed to the world. So if there is a kind of bug that can break maybe NVIDIA stocks or whatever, we don't we need to keep them secrets. Anyway, it never happened, but yeah. This is, let's say, the contract. Kubernetes, the names came from ALPS and Kubernetes. After a few beers, we found out his name. As I said, is an hybrid setup, virtual machine and HPC hardware. This makes enables us to have, for example, a cluster where you can have a very nice use case is SKA that they have, for example, Jupyter Notebook on the virtual part, and then they spawn the notebook itself on HPC, so they can run HPC workload through Kubernetes. Another example can be AI. So this is an example. So yeah, I will go comment on this later. So AI can be also a very interesting topic because AI is going more on the path of cloud native. You can see that in the cloud native, let's say, community is growing a lot, AI, and in this way you can use HPC hardware using Kubernetes. How it builds? So Kubernetes on ALPS version 2. Why version 2? Because version 1 was with crossplane. So we was using crossplane to deploy using Terraform and Ansible provider. We were building all the cluster, and it was working fine. Crossplane is very powerful, but at some point maintaining all this was very difficult, and for us, we decided to find another way. And in the meantime, Rancher with the new version helps us a lot because currently in a Harvester cluster you can, let's say, inject a normal node. I don't know if this is supported, but so you can have one Harvester cluster with also some bare metal nodes inside. And yeah, I think I'm running out of time, right?
Actually,
So okay, I will go just with the use case example. This is an inference service that we are developing at CSCS. So we are running on the ALPS nodes. We are running, for example, Olama. Currently, we are also starting deploying right now VLLM with Apertus. That is the Swiss AI model for serving it to the public. Then everything go through the Kubernetes networking. So egress, ingress, everything lightweight is on the virtual machine part, and we just keep the big nodes just for inference. So in this way, we don't trash, let's say, resources just for web interfaces or easy, let's say, things, because one single node is really expensive and it costs also a lot in energy. The entire machine is consuming around 12 megawatt of
How much were you recovering from the turbines?
the gain with the water. Yeah, 75 kilowatts, so nothing. But I mean, this.
Turn off the lights.
Yeah. It is, let's say, 1/3 of the cost of the energy to pumping the water. So it's not bad. I mean, in any case, our energy comes from hydroelectric, so it's greener than can be in the US, because in the US you just use energy also for the cooling, so the chillers and so are very expensive. So yeah, I will maybe. How much time I still have?
We also have to look over to Michael. Do we give him another 5 minutes?
Okay, I can speed up.
Huh?
Yeah.
Okay.
I go quickly through the operations. So when we need to upgrade through, for example, Harvester, it's easy. We go on the interface, you just click upgrade, and it will upgrade all the infrastructure. Rancher itself is nodes are updated via Ansible. Rancher, the application is upgraded via also via Ansible, and ArgoCD just via Helm chart. These are the only, let's say, manual thing that we do, because everything else, the downstream cluster and so on, are scheduled updates. We use Ansible with a dynamic inventory that takes all the nodes from Rancher and then upgrade all the nodes, and then QRD will take care of that. If we need to change the version of Kubernetes, we just go on our Terraform deployment. On each cluster, we can change the versioning of the Kubernetes, apply, and this is then done via Rancher. It's easy, never have problems. And yeah, Upgrade Manager already say that. This is the web interface of QRD, so we can check all the reboots of all the nodes during the upgrades and so on. It's quite nice to see the status of your upgrades. And yeah, so lesson learned. If you use infrastructure as a code from the beginning, helps you a lot, because if you start developing a cluster maybe from the web interface, and then you want to go on Tofu, this means that you need to convert everything to that. Yeah.
Sorry, I just have another question. Because I see that you're using so many open source tools
Yeah.
in Terraform from Archie. Why?
We are migrating to OpenTofu.
Okay, fine.
No, we already migrated. I mean, at least we are migrated to Tofu. We still have some Terraform stuff, but we are going out.
So the commission is, we're talking about Kibana 2, I think there will be the commission with
Yeah,
the
yeah, yeah.
Deeds will be the commission, and I was like, okay, Terraform is expensive too.
Yeah, we don't pay it anyway. But we
Now makes sense.
no, I mean, we don't pay because we are using the free version still.
Okay, wow, nice.
And because we don't resell, we don't pack it and we don't resell.
That's why, nice.
So we can just use it, but we prefer going to the path of open source anyway.
Yeah.
Yeah, set up multiple environment is also an advice, instead of having one single cluster with multiple kind of things. You focus on scalability and try to keep flexible your infrastructure, stay up to date. Yeah, because we are just 3 people managing everything, not full time, and the first year and a half we didn't upgrade anything. So then do all the upgrade was very very long, and yeah, that's. And another very important part is stick on the support matrix, because this also we did some error there, some mistakes. So we upgraded version of Kubernetes to the latest, but Rancher was not supporting the versioning, so we had some problems on that, but nothing that you cannot fix easily. And yeah, some use cases. As I said, we have more than 50 clusters, around now 500 VMs, and around 200 bare metal nodes. Some examples are, yeah, maybe Kubernetes. The most interesting part are the inference service, and also customers, let's say customers like SKA, Observatory, and yeah, and also the WellCG services are running on top of that. And yeah, if you have questions,
Yes.
more questions.